This is the Applied Calc Semester 2 Exam Review movie. Try saying that fast. Here we go. For problem number 1, we're evaluating an indefinite integral. You can see it's just a polynomial, so I'm going to use the power rule. It's negative 5x to the fourth plus 8x cubed plus 4. And the power rule is going to be negative 5x to the fifth over 5 plus 8x to the fourth over 4 plus 4x plus c. Let me do a little bit of reducing here. This makes a negative 1. This makes a 2. And so the final result is going to be negative x to the fifth plus 2x to the fourth plus 4x plus c. And if I go down the list over here on the side, that looks like letter A. Except it's not because of this 5. How about letter D? There we go. And letter D is the correct choice. I got to pay better attention. So far, so good. Let's move on to number 2. In problem 2, we're going to evaluate a definite integral. And you can see the limits of integration are negative 1 to 3. This is also just a polynomial, so we'll use our power rule again. And we'll see what we come up with here. So we're going to have negative x to the fourth over 4 plus 3x cubed over 3. We're going to do a little bit of reducing here to make this a 1, and this gets evaluated from negative 1 to 3. So let's just clean this up a little bit. Negative x to the fourth over 4 plus x cubed. And again, those limits of integration are negative 1 to 3. So we're going to follow the fundamental theorem, and this would be negative 3 to the fourth. That's going to be negative 81 over 4 plus 27 when you plug in 3 minus negative 1 to the fourth. So this would be negative 1/4 minus 1. And so I'm going to do a little math in my head here. This can be negative 81 over 4 plus 1/4. That'd be negative 80 over 4, which is negative 20 plus 27, and then plus 1. So that looks like it's going to be 8. And letter D is the right answer, so we're in good shape here. We're 2 for 2. Okay. Not bad. All right, let's move on to problem 3. In problem, spit it out, man. In problem 3, we're going to need to do a little U substitution here because we have a composition. So, as you know, we usually use what we call U substitution. So we're going to assign U to be that expression that got plugged into the fifth power, which would be x to the fifth plus 1. And then we take the derivative, that would be 15x to the fourth. And that means dx is du over 15x to the fourth. When we write our new integral, we'll have the integral of 15x to the fourth. And then we'll have u to the fifth, right? We're substituting u in there. And then we'll have du over 15x to the fourth. Now that's great news because these two terms cancel, and this is just a definite integral of u to the fifth. Indefinite integral of u to the fifth. Antiderivative, you know. Okay, so this is going to be u to the sixth over 6 plus c. And then don't forget, we plug the u back in, so that would be 3x to the fifth plus 1 to the sixth power over 6 plus c. And you might see that over 6 written as a 1/6 in front. And if we look over here at our answers, it is going to be letter B. There it is right there. So that's good news. That one wasn't too bad. And we continue our winning streak with these problems. Number 4 is next. In number 4, we're going to have to try some u substitution again. This time I'm going to choose that expression in the denominator. U is 2x squared plus 5. The derivative is 4x. Ooh, that's convenient, and that means dx is du over 4x. So when I rewrite this indefinite integral, I said that twice today, I'm going to have 4x, that's an x, over u to the third power. And then instead of du, I'm going to write dx. Instead of dx, I'm going to write du over 4x. Again, we get lucky. The 4x's cancel. And so this is just the indefinite integral of u to the negative 3 du. Our power rule, we add 1. So negative 3 plus 1 is negative 2. Be careful with that. This is going to be u to the negative 2 over negative 2 plus c. But we go ahead and put our u back in. And I'm going to write this as a fraction without the negative exponent. So this is going to be negative 1 over 2 times u squared. And u is 2x squared plus 5. And then plus c. And then I'm going to go over here on the letters and see if our streak continues. Negative 1 over 2 times 2x squared plus c is letter D. And again, that's the correct answer. That's good. There's a couple of other answers here they put in to try and trick us, especially this one. But that had a 4th power. And they had a squared in here, but no 2 in front. So D is the correct answer. All right. Not bad. Let's move on to number 5. In number 5, we have a definite integral, and we're going to have to use u substitution. So not only are we going to change the expression, but we're going to change the limits of integration. You see, we stay with u because u is good. So we're going to make u equal x plus 3. The derivative then is just 1, so du equals dx. But we're going to change these limits of integration. If we do u of negative 4 plus 3 is negative 1, so the top number is going to change. And if we do u of negative 7 plus 3 is negative 4, so the bottom number is going to change too. So when we rewrite this definite integral, we're going to have the definite integral from negative 4 to negative 1 of 5 over, and we do have u squared, but du is the same as dx, so I'm just going to put a du here. So we don't have anything cancel this time. Let's clean this up a little bit, and then we'll do the antiderivative. This written as a power is just going to be u to the negative 2, and then we use our power rule. Remember, we're adding 1, so negative 2 plus 1 is negative 1. So this turns into negative 5 over u. And we're evaluating that, negative 4 to negative 1. And so when we plug in negative 1, we get negative 5 over negative 1, which is just 5. And then we subtract off negative 5 over negative 4, which is 5/4. 5 is 20/4 minus 5/4 would be 15/4. And that is letter B. Yay, we got it. All right, there it is. Letter B wins for this problem. The key on this problem is if you change those limits of integration, you can stick with u. I know it's the saying, but it also works. And then just be careful with your minus signs as you plug this thing in. And the other thing is, on a power with a negative exponent, don't forget that we add 1, and it goes to negative 1, not negative 3. It's not like a derivative. Okay, number 5. Check it off the list. Let's move on. With problem 6, we're starting to get into some limits, some applications of integration. And one of the applications is that we can find the area between curves. So notice we have this y equals 2 on the top side. And on the bottom side, we have this negative 1 over x squared right here. All right, oops, I hit the wrong thing. This curve here is negative 1 over x squared. And so just remember that when we do the enclosed area, we're going to integrate the top curve minus the bottom curve. So we're going to integrate, and you know we're going from negative 4 to negative 2 because those are the boundary lines right here. We're going to integrate the region 2 minus negative 1 over x squared. And that is cleaned up as 2 plus 1 over x squared. The antiderivative of 2 is 2x. The antiderivative of 1 over x squared is negative 1 over x. Remember, this is x to the negative 2. You add 1. Okay, so be careful with that antiderivative there. And then we're going to put these limits of integration in. When we plug in the negative 2, that'd be negative 4 minus negative 1/2. So plus 1/2 minus, and then this is going to be negative 8 plus 1/4. Now, we got to distribute the negative sign, so don't forget this is turned into a plus and this is a minus. So essentially, if I do my math right here, I'm going to have 8 minus 4, which is 4, and then 1/2 minus 1/4, which is plus 1/4. So that's going to be 17/4, which is also letter B. And you can see that right here, okay? So again, be really careful with this little 1 over x squared thing here. That's x to the negative 2, and when you add 1 to negative 2, you get negative 1. And that's why we ended up here with negative 1 over x squared, minus 1 over x squared there. Okay, so that was problem 6. And let's see if we have any more applications moving forward here. On to number 7. Sure enough, in number 7, we have another application. This time we're trying to find the volume of the solid that's generated when you rotate this thing around the x-axis. And there's the rotation that's indicated with a little curvy arrow there. And so remember, we have several methods to compute volume. In this case, since our region sits right on the x-axis, which is the axis of revolution, when we do the cross-section, this is just going to be a solid disk. And so all we need to do is figure out the radius. Well, in the plane, we measure the radius as the top minus the bottom. For us, that's going to be negative x squared plus 4 minus 0. So that's just negative x squared plus 4. And the area of this disk is pi r squared. So the volume here is pi times the integral of that radius, which is negative x squared plus 4 squared dx. And we're going from negative 2 to 2 on those limits. You can see them right off the graph there. Now, since I'm cranking this thing out by hand, let's go ahead and expand that binomial. The power there, so it's negative 2 to 2. This is going to be, let's pretend this. I'm going to think of this as 4 minus x squared, just to make my life easier. So this is going to be 16 minus 8x squared plus x to the 4th. And then when I go through the antiderivative, I have pi times 16x minus 8x cubed over 3 plus x to the 5th over 5. And we'll integrate that, like I said, from negative 2 to 2. Okay, let's see if I can do all this math in my head here. So we've got the pi. Let's just multiply that by the whole thing here. When we plug in 2, we're going to have 32 minus 2 cubed is 8 times 8 is 64 over 3, and then plus 32 over 5. That's when you plug in the positive 2. When you plug in the negative 2, you get negative 32. Negative 2 cubed is negative 8, so that's positive 64 over 3. And then negative 2 cubed is negative 32. So this is negative 32 over 5. I'm going to run out of room here. And then we close this off. So let me squeeze this in here. Pi times, let's write out all these numbers. I've got a 32 plus a 32. This is a minus, this is a plus. 32 and 32 is 64. So this is 60, oops, goodness. 64. I got a negative 64 and a negative 64. That's negative 128 over 3. And I got a 32 plus a 32, which is a 64 over 5. Okay, so it looks like we need a common denominator of 15. 64 times 15 is like 960 over 15. And 128 times 5 is 640 over 15. And 64 times 3 is 192 over 15. And when you add all that up, you get 512 pi over 15. And lo and behold, there it is. Letter A, which happens to be the right answer. So we continue our streak. Okay. A little bit of extra crazy calculations at the bottom here, but you can see that we use what we call the disk method to crank out this volume. Okay, a bit of a mess, but here's our value down here. We did find letter A, so that's good news. We've got one more to go here. Let's do number 8. I think this video needs to end soon. I'm saying the wrong thing. On to number 8. So this last problem is another volume problem, and again we're going around the x-axis. But notice there's a gap between the region and the axis of revolution here. I just indicated that with a little green scribble. So what's going to happen is we're going to have a cross-section that has a hole in it. In other words, it's going to make what we call a washer, right? We have an inside radius and an outside radius, and when we draw this thing, the outside radius is going to come around, but this one's going to come around like this. And so essentially the cross-section area looks like this, and the region that we're trying to compute is here. That the radius of this red circle, that's from the x-axis up to the top curve, and the radius of the blue circle is from the x-axis up to the bottom curve. The top curve is the square root of x plus 2, and the bottom curve is just y equals 2. So when we set this definite integral up, and we're going to compute this from where the region is, from 0 to 4, it's pi, and then the large radius, the top radius, which is the square root of x plus 2 squared, minus the whole, which is pi times the small radius squared. The smaller radius is always 2, so that's just 4 pi. And we're going to do that definite integral. Okay, again, my best bet is to multiply this thing out. So let's see if I can squeeze this in here. Let's factor out a pi from both terms. So the pi comes from everything. When I square this, I get x plus 4 square root of x plus 4. And then I have a minus 4 here. Ooh, that's good news. I factored out that. Okay. So I just need to do the antiderivative of x plus 4 square root of x. I'm going to use a power rule on both these things. So don't forget we have our pi here. Antiderivative of x is x squared over 2. Now this one's going to be interesting. This is a fraction. It's a 1/2. I'm going to add a 1 to it, so that's 3/2. So that's 2/3. This is going to be plus 8/3 x to the 3/2. And we're going to evaluate that from 0 to 4. So hopefully I can do my math okay on this. Remember there's a pi here, and then let's plug in a 4. 16 over 2 is 8. 4 to the 2/3 happens to be 8, and I'll show you why. I'm going to do the 1/2 first. The square root of 4 is 2, and 2 cubed is 8. So this is plus 64 over 3. That's the first part. And then the other part, you get zeros for both of them. So that's just gone. So all I need to figure out is, what is 8 plus 64 over 3? Well, that's 24 plus 64, which is 88 over 3 pi, or 88 pi over 3. That is one of my answers. Is that the right answer? Let's go to the phones. Yes, it is. All right, well done. So, letter B it is. Okay. All right, we made it to the end of these multiple choice example problems. And I'll follow up with the other two applications in a separate video because this one needs to end. Thanks for listening and good luck on your exam.